Yeah, next topic is injection and detection in HPLC. Okay, let's first consider the HPLC pump. Okay, since uh, the high pressure, sometimes it's very high pressure is required, to pump is very important. So the quality of pump for HPLC is measured by how steady and reproducible a flow it can produce. Okay, here it has two you know the pumps here and there. Okay, and so if so a fluctuating flow rate can create detector noise and obscures weak signals. Okay, here look at that. This is solvent reservoir, and this is intake with filter. Then now it is intaked by here by the active inlet valve. That is uh, is operating, and but this operation is synchronized with uh, this one, this pump. This is a piston. Yeah. Now it is piston now push the liquid, and then it gives pressure to the liquid. Okay. And here the now this is a solvent now. It is moved. Okay, it pushed along this line. First, it passed the spring-loaded outlet valve. Okay, this valve maintains a constant outlet pressure here. The outlet pressure is important. Why? This is connected to the column, right? And then it this solvent now goes through this damper, right? This is damper. Damper, further reduces pressure surge. Yeah, pressure surge means that you see suddenly the pressure changes. Okay, there's pressure surge. Using this damper, it reduces pressure surge, and also here there is a cooling water. Yeah, cooling water. Yeah, now is circulating, and then this solvent is now enters the second pump. Okay, and this volume, the first one, the volume is 100 microliter, actually very small amount, and this one is 50 microliter. Okay, and now the solvent now goes to the column, yeah, at constant pressure. Okay, gradients made from up to four solvents are constructed by proportioning the liquids through a four-way valve at low pressure and then pumping the mixture at a high pressure into the column. Although not shown here, for the gradient illusion, you need several solvents. Okay, so by adjusting the mixing ratio. Okay, and then the mixed solvent enters the column. Okay, and in that case, the for example the valve. For example, if you have four solvents, and then you need a four-way valve. Okay, the gradient is electronically controlled and programmable in 0.1 volume percent increments. Okay, yeah, here this is the structure of injection valve. Okay, now you inject your sample here through this syringe. Now it's injected. This is the load position, yeah, before the uh, uh, injected to the column. Okay, you see it has one, two, three, four, five, six, six valves here, and then they are interconnected. Okay, and this is the loop. Okay? And then before injecting into the column, now you have to have a precise amount of your sample. Okay, look at that. Now syringe is now you inject your sample, and then here follow this blue line. Then this one now, you know, past this part, and then here, and then now here, and then to the waist. Okay, so if you keep, you know, pushing the syringe, the piston, and then liquid uh, is filling this part. Okay, and what about the other line? Yeah? Here solvent in this case now enters this way, and then uh, it goes to column. Okay, so this is before loading. This is actually loading way. Okay, before injecting the your sample to the column, right? And then only solvent now is what enters the column, and then what? And then you know change it, this position. And then these two valves are disconnected, and will be new connection from here to there. This one and this one and this one. Okay, and after turning this valve, now although in this case, although you inject your sample, that sample doesn't go to this loop, but it goes to the waste. Yeah, and then in the meantime, since you changed this valve, and then there is a new connection here. Look at that, this part and this part and this part. Okay, and then since you still keep what, flow this solvent, right? Now your sample now is confined within this tubing, right? This amount. Yeah, and then since there's was a new connection was made, and then when solvent the solvent now carries, okay, carries this your sample, you know, whose amount is precisely controlled by this loop. Okay, and then it carries, and then now your solvent and your sample, yeah, this one goes to the column. Okay, this way. This way is one of the way to inject your sample, precise amount. Okay? So sample loop having a fixed volume. Okay, this is a sample loop, and depending on the tube size, sample volume is maybe between 2 to 1,000 microliters. Okay, yeah, it can be very precisely controlled. Okay, rotation of the valve. This one now 60 degree. Okay, the sample is injected into the column. Okay, yeah, and let's consider now the spectrophotometric detectors. There are the many kinds of detectors that can be used in HPLC. Okay? Let's first consider the characteristics of ideal detectors. Okay, ideal detectors should be sensitive to low concentration of every analyte. Okay, it should provide a linear response, and it must not broaden the elute peaks. Okay, and it is insensitive to changes in temperature and solvent composition. Okay, and also it requires a small detector volume, less than 20% of that chromatographic band. Okay, and back pressure available to prevent gas bubble formation. Okay, because the bubble creates noise. Okay, and this table 3 lists different detectors. Wow, there are a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At least 10 detectors that can be used in liquid chromatography. Okay, and then this table compares the commercial HPLC detectors. For example, ultraviolet detector. I think this is the most widely used detector. Okay, because most organic molecules are uh, they absorb ultraviolet the radiation. Okay, so with this detector, the approximate limit of detection is 0. 0.1 to 1 nanograms. Okay, this is useful with gradient. Okay, yes, and reflect in this detector. Yeah, this yeah, I will explain in detail shortly. But this kind of detector has a very poor detection limit. Okay, and evaporative light scattering, charged aerosol electrochemical, okay, and the fluorescence and the nitrogen conductivity to the mass spectrometry, and for the transfer infrared. Okay, those okay detectors are available. Okay, and then we'll see in detail in the next lecture. Okay, let's stop here.